Okay, so this website I came across last year, someone shared with me called Brilliant, and basically every week they send out a bunch of fun trivia questions. So the research question here is, are EMU students different from Brilliant members, so people who are subscribed to this website, in terms of physics knowledge? So there's all these different categories on the trivia site, and physics is one of them. So what we're asking here is, are EMU students different from? First thing to cue in on there is that phrase different from, because that's going to be important as we're moving forward in deciding whether we want a one-tail or two-tailed test. Notice that it's not asking, are EMU students better than, or are EMU students worse than? It's just, are EMU students different than, in either direction? This is what we're going to do. Take a sample of EMU students, random sample of course, figure out the percent of our sample that get this particular physics question right, and compare it to the overall average on Brilliant. Not a great design, but this is more to get the sense of what a hypothesis test is. So here's the question. You can pause it and take it yourself if you want, the physics question. Basically, we want to know what's going to happen as the van slams on its brakes. And if you've ever been in a car that slams on its brakes, or if you've ever slammed on your brakes, I'm about to give the answer, so pause it if you don't want to hear it. But the person will go forwards, they'll lunge forward. The balloon, however, filled with helium relative to the van, it's going to go backwards. So the correct answer there is A. And this is true here, that the average 49% was the amount of Brilliant members that got that correct. So that's what your population mean is. Standard deviation here, this is somewhat fabricated, but we'll use it for the sake of this question. First question, notice that steps 1 and 2, we don't even need to know what our sample did yet. It's set up, we're setting up our rejection zone, we're setting up the problem before we really even look at where our data falls in the scheme of things. So what are the null and alternative hypotheses? Well, our null hypothesis should always be mean equals something. So null would be nothing. If there's no difference between EMU students and your average Brilliant puzzle solvers, what percent of EMU students should get this question correct? And that would be 49%. So we would put here 49%, or 0.49 if you want. Alternative hypothesis, why did I choose mean not equal to? Again, going back to what I said on the first slide, because we're saying different from, could be that they're much worse, could be that they're much better. We're just checking if they're different. So we use the two-sided not equals to sign. So we might be able to reject because EMU students are so bad. We might also be able to reject this null hypothesis because EMU students are so good. So this would be 0.49 here and 0.49 here, or 49% and 49%. Your choice. You can go through the problem with percentages the entire way, or decimals. Step 2, what's the alpha level of significance? We're going to assume 0.05. Since it is a two-tail, that would give us our critical z of 1.96. In other words, when we go through the calculation in step 3 of our particular z value, if it's either above a positive 1.96 or below a negative 1.96, we're going to be able to have some pretty strong evidence against the null. We're going to reject the null. So we conducted. It'd be nice to do this in class, but we didn't have time. So let's say that we had some random sample of 25 students. I should have put that in there. And 65% of them got it correct. So first question here, what's the value of our z statistic? What p-value does this yield? Go ahead and pause this. Also, keep in mind that our sample size is 25 and we had 65%. of the EMU students get it correct. You're going to need those two values. Okay. So here, this is a little bit weird to understand in terms of a sample mean, but this was our value for our EMU sample, was 0.65. 0.49 was our null hypothesis mean. 0.30 was the standard deviation we were using, and we had a sample of size 25. And you only knew that because I told you that. I didn't write it up here. When you go through this calculation, you should get a z value of 2.67. Notice this now is tied to our specific sample, unlike this z star that we could look up in table A to get that 1.96, or we might just know that for a two-tailed test with a alpha value of 0.05, your z star is always going to be 1.96. P-value here is probably the hardest part of the problem. So we have a 2.67 z-score. We want to know what percent of the distribution is out in the tail, so beyond the 2.67. And then we need to double it because we're doing a two-tailed test. So this would, getting the percentage that's to the right of this would give us the percentage in one tail. But since we're running a two-tailed test, how do we know that? Go back to step 1. That's where we said, because our EMU students different from, we didn't say better than or worse than. So because we're allowing for the chance of rejecting in either tail, we multiply this tail value by 2, and that'll give us our p-value. So let me zip through these here, show you what's going on. So our z-value was 2.67. This is where our particular sample was sitting at. We want to know the percentage in this tail. Table A doesn't give us that, right? Table A gives us the portion less than a given z-value. So we could look up 2.67 on the table A, and we'd get 0.9962, but that's the portion to the left. That's called the body of the distribution. We want the tail. That's why we subtract this from 1 to get 0.0038. So that's the portion in one tail. For our test that we're conducting right now, we're doing a two-tailed test. So we also need to add in the same amount from the other side of the distribution by doubling this number. And that's how we get our p-value of 0.0076. Step 4, what's our decision? Do we have good evidence against the null? We can look at this two ways. So is our 2.67 further out than our 1.96 that we needed to get? And it is indeed. It's further out in the tail than that cutoff value, that critical value. So that would tell us we have good evidence against the null. We should reject it. We could also look at our 0.0076, which is lower than our threshold of 0.05 that we were going to decide to reject if our p-value is lower than this value, and it was indeed. This number is lower than this number. So we reject the null either way, and as someone asked at the end of class, these two decisions will always match up. What you decide based on comparing the z to the z star, and what you decide based on comparing p to alpha, they should match up. If they're not giving you the same decision of how to handle the null, then go back and look at your steps for each one, because they should always match up. And both cases here are telling us to reject the null. Finally, our conclusion. So what does it mean that we reject the null? Remember, our null hypothesis was that there is no difference between EMU students and these brilliant puzzle solvers in terms of physics knowledge. And we reject that to say that, yeah, we do have some evidence that EMU students are different from puzzle solvers. And since we were in the positive direction here, we can even say, even though we conducted a two-tailed test, so initially we knew we could reject in either direction, with EMU students being really bad or really good compared to your brilliant puzzle solvers, our particular test gave us evidence that we are better. Not only are we different, but that EMU students are better.